Okay, so let's get started. Simplifying radical 48 over 6. Well, what we're going to do is we're going to take a look at 48 and we're going to say to ourselves, what is a perfect square that goes into 48? 48 divided by 2 is 24. That's not a perfect square. Divided by 2 again is 12, so it's going to be 12 times 4, 16 times 3. Alright, so I went through it and I found the largest perfect square. It's going to be 16 times 3. So this is going to come out to be 16 times 3 over top of 6. The square root 16 is going to come out as a 4 root 3 over 6. Now we have this whole number part, the 4 and the 6, that will reduce to give you 2 root 3 over 3. Now notice that this 3 is not underneath the square root sign, so it cannot cancel. This is 2 times root 3, which means root 3 plus root 3 all over 3, not a root 3, so that needs to stay the way that it is. That's kind of interesting. I kind of like that. I think I'm going to leave it like that, and we'll move on to the next one. Root 20 over 5. Now, there's going to be two ways that we can handle this. One way to deal with root 20 over 5 is to take a look at root 20 and to remember that that's going to be 4 times 5 over top of root 5, because 4 times 5 is 20. This 4 can come out as 2 root 5 over root 5. Now that's different. This was root 3 over 3, but this is root 5 over root 5. So this is 2 times root 5 divided by root 5. So in this case, we can reduce them, and we're going to get a final answer of 2. Now, another way to do this question, perfectly legal, just as good, we notice that we have we have a quotient of two radicals here. So that could be the radical of the quotient, since they both have the same index number of 2, and they're both being square rooted, and we're asking for the quotient of that. We can change it into this, which will give us radical 4, which of course we know is 2. Both ways work beautifully. Both are full marks. This one, well, see, this is going to give you a problem. If you try to do 4 divided by 9, you're going to get a decimal. Then the square root of that decimal is going to be ugly. No matter what you do, it's not going to be accurate. But if we take this radical of a quotient, and if we change it to the quotient of two radicals, we can very easily reduce this to 2 over 3. Because the square root of 4 is 2 and the square root of 9 is 3. And we don't get any of those messy decimals. And then it wouldn't be accurate. This is the accurate answer. Okay, so over here. A couple of different ways we could handle this, I guess. I've got 24 over root 24 over root 2, so I could change that. We could make it 16 over 2. 24 over 2. So that could become 8 root 12. And then the 12 still has more that can come out of it, right? It's not in lowest, simplest terms. It can be 4 times 3. So then the 4 comes out as a 2. It mingles with the 8. We get 16 root 3. That's one way to do it. And perfect marks. I love it. Perhaps here's another way. 16 divided by 2, we already know is going to be 8. So I could do this as an intermediate step. I could then look at 24. 24 is going to be, let's see, 24. How about 4 times 6? 4 is the largest perfect square that goes into 24. We'll have a root 2 out here. So the 2 will come out and it'll give us 16 root 6 over root 2. Notice the root 6. The root 6 could be divided up into root 2 and a root 3 over a root 2, because root 6, remember, now neither one of these are perfect squares, but I'm not trying to find a perfect square. I'm trying to get rid of the root 2 on the bottom. Root 6 is going to be root 2 times root 3. So I could get this, and we could reduce those out, and it leaves us with the same answer as 16 root 3. Granted, this way looks a lot easier. I would prefer to do this way, but this is perfectly fine as well. Okay, so now this one. Well, maybe this is a nice way to do it. You've got your 2 over 10. That's going to reduce to give you a 5 on the bottom. The root 12 is going to give you 4 times 3. The 4 is going to reduce and come out, and it's going to give you 10 root 3. I skipped some steps there that you might want to put in. I've got a root 3 on top. I've got a root 3 on the bottom. The root 3 on the bottom is being multiplied, so we can reduce, and that's going to give us 1 over 10. Last one over here. Other ways to do that, by the way. Other ways you could go about doing that. This one, I'm thinking what I would like to do personally is maybe take the 24 and come up with root... Well, see, I see the 15 here. The 15 jumped out at me because I got a root 5 at the bottom. So 15 is 3 times 5. So I'm thinking I might as well do 5, 3, 2. So what I did was, and I'm just thinking ahead here a bit, I took this 15 and I broke it up into root 5 and root 3. The only reason why I did that in this particular case is because I see on the bottom I have a root 5. They're going to be able to reduce with each other. The 24 and the 2 are going to reduce, giving me 12, root 3, root 2, which I'll change back to root 6. Other ways to do that, I could have put the 15 and the 2 together to get root 30. Let's take a look at that real quick. I'll grab another piece of paper. So let's say I had 24 root 15. That was root 2, 2 root 5. Here's another different way of doing the exact same question. Could have been 24 root 30 over top of 2 root 5. 30 is going to, well, 24 divided by 2 is 12. 30 is going to be root 5 times root. Nope, lying. The 24 and the 2 are going to give me 12. The root 30 is going to give me root 5 times root 6 over top of root 5, which is 12 root 5 root 6 over root 5. They reduce, and it's 12 root 6. Let's see if that's the same as I got before. It was. Both are equally good. I'm happy with whichever one you are comfortable with. This one here. This is an interesting question. Very, very interesting question. Please note that you cannot do this. Let's see what I got here, 45. Please note that you cannot do this. This is a no, because what you're doing is you're reducing with a subtraction here. This whole thing is over top of the bottom one. They cannot reduce like that. What you're doing is this. And that's a no-no. Okay, so let's take a look at this. I got 45, so it's 3 minus 2 root 9 times 5. The 9 will come out as a 3, so I'll get 3 minus 6 root 5 over 3. Now what I can do on top is common factor. I can common factor out of 3. See what happened there? I took a 3 out, so if it goes back in, it would go back in as 3. It would go back in as negative 6 root 5, so I took the 3 out. Notice that this is this bracket times 3 divided by 3, and that's going to give you 1 minus 2 root 5 over 1. 1 minus 2 root 5. I'm not sure what that is. I meant it to be a 2. There you go. Okay, ladies and gentlemen, you're done lesson 6. Off you go on some of the homework, okay? There you go.